So let's take a look at one last concept from this idea of solutions, and that is dilution. Right? When these are sort of special case situations. If you take a compound, so if you took 1 mole of NaCl and you set it down into 1 liter of solution, we would know that that would be a 1 molar solution of NaCl. Mole, liter. Now, if you then take that 1 liter of solution and you were to pour it into a bigger vat and dilute that up now to 5 liters, the number of moles of NaCl wouldn't change. It would still be 1 mole of NaCl dissolved in 5 liters. But the concentration would. We have added 4 times as much water, so to speak, and so the concentration would go down. It would be less concentrated. Now, we can take that fact and take the number of moles of NaCl present and then redissolve it in our liters of solution, just like we would always do, to get our new concentration. But we can also take advantage of the fact that when you have the known concentration and known volume equation shown here that relates the molarity and the volume of one solution with the molarity and volume of another solution where you've added more liquid. So let's take a look at what I mean by this. So if you have a 25 milliliter solution of 12 molar H2SO4, 25 ml solution of 12 molar sulfuric acid, and you dilute that, you diluted it to 85 milliliters, you could ask, what would be the new concentration? Well, we can take advantage of the fact of that from this balance equation, M1V1 is equal to M2V2, we can take advantage of this equation that relates molarity and volume, the number of moles, to molarity and volume, the number of moles. You can then create a new solution. And what's nice about this is that you don't necessarily have to convert everything into liters, because as long as you're working within the same units, you can use this relationship, the fact that it cancels. So let's take a look at, if we know that this is a 12 molar solution of H2SO4, that is 25 milliliters, we know that it was equal to a new solution that's 85 milliliters times its concentration, our unknown concentration. Now, you rearrange and solve, milliliters cancel, and you're left with the following. The new concentration would be 3.53 molar, which makes sense. We've increased the volume by 3 or 4 times, and so the concentration should decrease by a similar amount. So this represents another way of generating a solution of a fixed concentration. So right now we have 2 ways of doing this. So if we wanted to go into the lab, we wanted to make a 0.100 molar Cl- solution. We wanted to make, we'll say 150 milliliters of it, using something like sodium chloride. How would we do that? Well, now we have 2 options. Weigh out a certain number of grams of sodium chloride, convert it into moles of sodium chloride, and then dissolve that in the requisite amount of water to create a 150 ml solution. The other option is to take a known volume, what we call a stock solution, typically acids and other things, other reagents that you purchase in bulk that are aqueous, come as stock solutions. Using a stock solution of known concentration, 2 molar stock solution, you could then measure out a certain number of mils of that solution, which relates to the moles of NaCl, and then dilute up to 150 mils of solution again. So this provides two ways of generating a solution, either going into the lab and weighing out a fixed quantity, or using a pre-made stock solution and diluting to the correct value. Depending on which situation you're working in, oftentimes it's more efficient.